Water completes the mix, part 2. This part will start on page 73. Ask Mark, wait a minute, when I look at the charts, as the air temperature rises in the far left column, the relative humidity is also increasing. Didn't you just say the opposite? You have sharp eyes, just what a weather forecaster needs. You're right, the chart does show the relative humidity rising as the air gets warmer. Higher temperatures have higher humidity to start with because the warmer air can hold more water vapor in the first place. But the getting it right rules still hold. Let's go back to the example. If you had started at 68 degrees Fahrenheit instead of 58 degrees Fahrenheit, the wet bulb temperature would have been higher to start with, and you would have started with a higher relative humidity, greater than 51%. If the air had then warmed to 70%, the difference between the wet and the dry bulb temperatures would increase, and the relative humidity would drop. Air temperature up, relative humidity down, just like the rule says. Relative humidity is a tricky concept. A lot of grown-ups, I explain it to you, have a hard time understanding it. You'll get more comfortable with it as you use it more, and who knows, you may be explaining it to grown-ups before long. Because warm air can hold more water than cold air, meteorologists like to measure the humidity of the air as a percentage of the amount of water that the air can hold at a given temperature. This measure is called relative humidity. Forecasters getting it right rules. The relative humidity of the air changes depending on the air temperature. Cool air can't hold as much moisture as warm air, so as the temperature drops, the moisture in the air gets closer to the maximum amount it can hold. Air eventually cools to a point where it can't hold any more moisture, 100% relative humidity, and has to start letting go of it, so dew forms. Weather lore. Try your hand at a meteorological explanation for this weather saying, then see how yours compares with the official one below. If Miss Spider hangs her wash on the line, the weather will be fine. But today is not laundry day. Answer. Wash on the line is a poetic way of noticing the dewdrops clinging to the intricate lines of a spider's web. And you know that dew in the morning means, see page 69. 69. You know that dew in the morning means dew on the grass, rain will never pass. Be a meteorologist. Measure the humidity. Determine the relative humidity for 1 week and record it in your weather log. Observe the temperature and how sticky or dry it feels. Are storms more likely to happen on a dry day or a humid day? How does the weather feel on a cool day when the humidity is high as opposed to a warm day? Quick take forecasts. The relative humidity is 40% when dark clouds arrive and a cool rain begins, causing the temperature to fall. What happens to the relative humidity? Answer. It goes up. The cooler air can't hold as much water vapor as the warmer air, so the moisture in the air gets closer to the maximum amount possible, raising the relative humidity. Don't sweat it. On a hot day, have you ever heard someone say, it's not the heat, it's the humidity that's making me so uncomfortable? The amount of water vapor in the air affects how efficiently your body can release heat and cool you off. When there is less water vapor in the air, your sweat can evaporate, see page 65, from your skin. But if there is a lot of water vapor already in the air, your sweat doesn't have anywhere to go, so it just sits there, making you feel sticky and even hotter. Forecasters getting it right rules. In warm weather, a higher relative humidity gives the weather a hot, sticky feeling. In cool weather, a higher relative humidity gives the weather a damp, raw feeling. Higher humidity during the day often is clue that precipitation is nearby. Ask Mark, why does a summer day with a temperature of 90 degrees Fahrenheit feel so much hotter in Tennessee than it does in Arizona? The air in Arizona is very dry, so a summer day feels hot but tolerable. A summer day in Tennessee, however, forces people into air-conditioned buildings for relief. In the southeastern United States, where warm, moist air arrives from the tropics, the air is very humid, slowing the evaporation of perspiration from your skin and making you feel hot and sweaty. A 90-degree Fahrenheit day in Arizona would typically have a wet bulb temperature of 70 degrees Fahrenheit, which gives us a relative humidity of 36%. A 90 degrees Fahrenheit day in Tennessee, however, would most often have a wet bulb temperature of 80 degrees Fahrenheit. Figure out the relative humidity. How do the relative humidities compare? Answer. The relative humidity, see pages 134, 135, in Tennessee would be 65%. Whew, crank up the air conditioner. That's it. That ends on page 77.